It has now emerged that on October 13th, 2025, interstellar visitor 3I Atlas allegedly sent a signal not with sound or radio, but with light, pulsing in a sequence too elegant to be random. 5, 8, 13, the same golden code etched into galaxies, sunflowers, and the blueprint of creation itself. Yet just as the pulses began, our satellites went dark, cameras blinked out, the official record erased, accident or design. Stay with me to the end, because we might have just been contacted, and the message hidden in that code may be what humanity has waited centuries to hear. If these mysteries have you on edge the way they have me, hit like and subscribe so you don't miss a single revelation as this story unfolds in real time. Tell me in the comments where you're watching from, what time it is there, and if you think we're getting the whole truth, or just the version they want us to believe. And if you want this community to grow stronger, share this video on X, Facebook, Reddit, or even your private chats. You are the fuel behind this search for truth. Thank you for having our back. Part 1. The Pulse Heard in Numbers. On October 13th, 2025, something happened that most of the world missed entirely. The date itself carries weight for those who track cosmic coincidences and historical echoes. It marks precisely 108 years since 70,000 people gathered in Fatima, Portugal, and witnessed what they described as the sun dancing in the sky. But we're not here to talk about miracles from 1917, at least not yet. We're here because on that exact anniversary an interstellar visitor may have spoken to us in the only language that transcends culture, biology, and planetary origin: mathematics. According to researcher David Sarida, the object in question, 3I Atlas, did something comets and asteroids simply don't do. It pulsed, not randomly, not chaotically, but in a sequence so precise. Though still not verified by NASA or other official institutions, these findings sent ripples through the astronomy community. 5 pulses, then 8, then 13. If you know anything about mathematics or patterns in nature, those numbers should make you sit up a little straighter. This is the Fibonacci sequence, the mathematical fingerprint that appears in everything from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. Each number is the sum of the two before it: 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on into infinity. Let me be clear about what makes this unusual. Comets sublimate as they approach the sun. Ice turns to gas, jets of material spray out in directions determined by the object's rotation and composition and solar heating. These outbursts are messy, irregular, driven by physics that looks nothing like a carefully timed sequence. Natural objects in space follow the rules of thermodynamics and orbital mechanics. They don't count, they don't encode messages, they certainly don't pick specific numbers from a sequence that humans have recognized as special for thousands of years. And yet, if Sarida's observations are accurate, that's precisely what 3I Atlas appeared to do. The Fibonacci sequence isn't just mathematical trivia, it's woven into the fabric of how nature builds itself. The ratio between consecutive Fibonacci numbers converges on phi, the golden ratio, approximately 1.618. This number shows up everywhere: the proportions of the human body, the structure of galaxies, the branching of trees, the curves of hurricanes. Ancient architects used it to design temples. Renaissance painters used it to compose masterpieces. Biologists find it in DNA spirals and population dynamics. If you wanted to communicate with another intelligence across the vast emptiness of space, using Fibonacci would be a brilliant strategy. It's a pattern any technological civilization would likely discover as they studied their own world. This is exactly the kind of signal that SETI researchers have spent decades hoping to find. Not a random burst of radio noise, but something structured, intentional, unmistakably artificial. Prime numbers have long been considered the most likely first message because they can't occur naturally in regular patterns. But Fibonacci might be even better. It says, we understand growth, recursion, the mathematics that governs living systems. It says, we've looked at spirals and seen the same numbers you see. It's a handshake across the cosmic distance, written in a language older than any human tongue. But here's where the story gets strange, and where our investigation truly begins. Just as these alleged pulses occurred, NASA's Solar Dynamics Observatory reportedly went offline for maintenance. The feed cut out, the data stream stopped. And this wasn't the only blackout. The Mars Reconnaissance Orbiter's high-rise camera, one of the most powerful imaging systems we have pointed at another planet, had gone silent weeks earlier on October 1st, 2025. The Psyche space probe experienced a communications blackout from September 1st through 5th. 3 separate instrument systems, 3 separate missions, all experiencing gaps in coverage during the exact window when an interstellar object was potentially broadcasting mathematics at us. Is this coincidence? Technical failures are common in space operations. Instruments age, electronics degrade in the harsh radiation environment beyond Earth's protective magnetosphere, and maintenance windows have to be scheduled months in advance. Any one of these blackouts, taken alone, means nothing. But all 3, clustered around the same narrow time frame, during an event that might represent the most significant discovery in human history. That pattern is harder to dismiss. Either we're looking at the longest string of bad luck in recent space exploration, or someone, somewhere, decided we shouldn't see what was happening. The timeline tells a story even if we don't yet know what that story means. September 1st, Psyche goes dark. October 1st, Hyras stops returning images. October 13th, the Fatima anniversary, the alleged Fibonacci pulses, the SDO blackout, each date a domino falling, each blackout a piece of data we'll never recover. In science, we're trained to work with what we have, to build theories from evidence and adjust those theories as new evidence arrives. But what do you do when the evidence itself is withheld? What do you do when the instruments that should be watching go blind at the critical moment? This is the central question we're going to explore together, and it's not a comfortable one. It means accepting that we might be investigating not just what happened, but what we were prevented from seeing. It means entertaining the possibility that the greatest signal in human history arrived on schedule, was detected, and then quietly archived away from public view. Or it means accepting that we're pattern-seeking creatures so desperate for meaning that we'll construct elaborate narratives from coincidence and instrument failure. Both possibilities are unsettling, both deserve serious investigation, and both lead us deeper into a mystery that touches on mathematics, history, mythology, physics, and the very nature of how we decide what's real. The numbers 5, 8, 13 hang in the air like a question asked in a language we're only beginning to understand. Behind them lies a cascade of implications that will take us from interstellar space to particle physics, from medieval poetry to artificial intelligence, from the surface of Mars to the sun-scorched orbit of a visitor from beyond our solar system. This is a story about pattern and meaning, about the gap between what we observe and what we're told, about the possibility that on one October afternoon, while most of humanity scrolled through feeds and worried about ordinary things, the universe leaned in close and whispered a secret we almost missed. Part 2, a language written in spirals. You've probably seen the Fibonacci sequence without realizing you were looking at it. Every sunflower head contains 2 sets of spirals, one curving clockwise and the other counterclockwise. Count them carefully and you'll find the numbers are consecutive. Fibonacci numbers, 21 and 34, or 34 and 55, or 55 and 89, depending on the species. The seeds pack themselves into this pattern because it's the most efficient use of space, allowing the maximum number of seeds to fit into the available area. Evolution didn't learn this from a textbook. The mathematics is built into the physics of growth itself. The chambered nautilus builds its shell in a perfect logarithmic spiral that follows the golden ratio. Each new chamber is phi times larger than the previous one, creating that iconic curve that's become a symbol of natural perfection. Hurricanes spiral according to the same mathematics. Galaxies spin their arms outward in golden spirals containing billions of stars. The proportions appear in the human face. The distance from your chin to your eyebrows compared to the distance from your eyebrows to the top of your head approaches phi. Your fingers from palm to tip contain bones that decrease in length according to the golden ratio. We are quite literally built from this pattern. This is why SETI researchers have always expected that any deliberately transmitted signal would likely contain either prime numbers or Fibonacci sequences. These aren't arbitrary human inventions, they're discoveries, mathematical truths that exist independently of who finds them. An alien civilization on a planet orbiting a star 30 light-years away would discover the same Fibonacci sequence we know, because it's inherent to spiral growth and efficient packing. They'd find the golden ratio in their own biology, their own planetary structures, their own galaxies. If you want to say hello to someone who evolved under a different sun, speaking a language you could never pronounce, Mathematics is your best bet. Numbers don't care about biochemistry or culture. 5 plus 8 equals 13 everywhere in the universe. This brings us back to David Serida's claim about 3i Atlas. According to his observations, the object emitted a burst of 5 pulses, followed by 8, followed by 13. Then silence. It's a fascinating choice if you're designing a message. The sequence is long enough to be unmistakably deliberate, but short enough to be repeated and recognized. You're not overwhelming the receiver with data. You're offering a simple proof. I understand recursion. I understand the mathematics of growth. I know you'll recognize these numbers because any civilization with telescopes and mathematics will have discovered them. Now that I have your attention, you'll be watching closely for what comes next. Compare this to what we expect from natural objects in space. When a comet approaches the Sun, solar radiation heats its surface, turning ice directly into gas in a process called sublimation. This outgassing creates jets of material that stream away from the nucleus, forming the characteristic tail that always points away from the Sun regardless of the comet's direction of motion. These jets are chaotic, influenced by the comet's rotation rate, its composition, where the ice deposits are located beneath the surface crust. Sometimes a comet will have multiple jets. Sometimes they'll pulsate as the object rotates and different areas face the Sun. But they don't produce clean, countable pulses in a mathematically significant sequence. That would require timing, control, intention. This is where we have to pump the brakes slightly and introduce some necessary skepticism. Everything I've just described relies on Serida's observations and interpretations. These claims have not been verified by NASA, the European Space Agency, or any other official astronomical body. No peer-reviewed paper has confirmed the Fibonacci pulse sequence. We don't have multiple independent observers reporting the same phenomenon. This is crucial to keep in mind. Science doesn't advance on single claims by individual researchers, no matter how compelling the story. It advances on repeatable observations, on data that multiple teams can examine and verify. Without that verification, we're in the territory of interesting hypothesis rather than established fact. But here's the thing about interesting hypotheses. They're interesting precisely because they could be true. The absence of official confirmation doesn't mean the observation is false. It means we're in that uncomfortable zone between detection and verification, between seeing something and knowing what we've seen. History is full of discoveries that started with a single observer noticing something odd, something that didn't fit the standard model, and then spending years trying to convince the broader community to take a closer look. Galileo saw moons around Jupiter. Henrietta Leavitt saw patterns in variable stars that would eventually let us measure the universe. Fritz Zwicky noticed that galaxies were moving faster than they should and proposed dark matter decades before anyone took the idea seriously. The question becomes, how do we evaluate a claim like Serida's when official sources are silent and data feeds are interrupted? We look at what the claim predicts, what it would mean if true, and whether the pattern holds together when you examine it from multiple angles. We ask whether the mathematics itself supports the interpretation. We look for corroborating details, timeline matches, other anomalies that might point to the same underlying truth, and we stay honest about what we don't know, about where evidence ends and speculation begins. Pattern detection is a fundamental survival skill for humans. We evolved to see faces in clouds, to hear footsteps in rustling leaves, to find predators in ambiguous shadows. This served our ancestors well, but it also means we're prone to seeing patterns that aren't really there. This tendency has a name: apophenia. We'll come back to this concept later because it's critical for understanding how we might misinterpret natural phenomena as designed signals. But it's equally important to recognize that if an intelligence wanted to communicate, it would deliberately craft a signal to exploit our pattern recognition abilities. You wouldn't send random noise and hope someone decodes it. You'd send something that lights up the pattern detection circuits in the receiver's brain, something unmistakable and compelling. 5, 8, 13 does exactly that. It's simple enough to recognize immediately, but specific enough to rule out most natural explanations. If this were the opening move in a contact scenario, it's brilliantly designed. So we're left suspended between two possibilities, and the only honest position is to acknowledge both. Either we're witnessing the human mind doing what it does best, finding order in chaos and constructing meaning from coincidence, or we're seeing the first deliberate mathematical message from beyond our solar system, timed to arrive on a historically significant anniversary and promptly buried under a cascade of convenient instrument failures. The mathematics is real. The Fibonacci sequence is real. The golden ratio appears throughout nature and would be recognized by any technological species. Whether 3i Atlas actually emitted 5, 8, 13 pulses on October 13, 2025 remains unverified. But the question has been asked, and questions like this don't go away just because official sources remain silent. Part 3. Fatima and Atlas, a century-old mirror. Let's travel back to October 13th, 1917. Portugal is 3 years into World War I. The country is exhausted, divided, anxious about the future. In a small agricultural region north of Lisbon, 3 shepherd children have been claiming for months that a luminous figure appears to them on the 13th of each month, delivering messages about prayer, penance, and future events. The Catholic Church is sceptical but intrigued. Word spreads. On this particular October day, somewhere between 30,000 and 70,000 people converge on a field near the village of Fatima, many of them hoping to witness a miracle, many others there to debunk what they assume is childish fantasy or religious fraud. What happened next has been debated ever since. Multiple witnesses, including journalists, skeptics and believers alike, reported that after a period of rain, the clouds suddenly parted and the sun appeared to move in impossible ways. Descriptions vary. Some said it spun, others that it danced, others that it plunged toward Earth before returning to its normal position. Colours rippled across the sky. People's wet clothes dried instantly in a sudden blast of heat. The event lasted approximately 10 minutes, and then the sun resumed its normal appearance. To this day, no scientific consensus explains what so many people saw, though theories range from mass hallucination to atmospheric optical effects to retinal distortion from staring at the bright sky. Fast forward exactly 108 years, October 13th, 2025. An object from interstellar space, following a trajectory that brought it from beyond our solar system, allegedly emits a mathematical sequence at precisely the moment when Earth's primary solar monitoring satellite goes offline. The coincidence of dates is exact. Not approximately the same time of year, not within a week or two, but the precise calendar anniversary of an event that remains one of the most widely witnessed unexplained phenomena of the 20th century. If you're the kind of person who believes coincidences are just coincidences, this probably doesn't move you. If you're the kind of person who sees patterns and wonders whether they might mean something, this demands investigation. The number 108 carries significance in multiple mystical and religious traditions. In Hinduism and Buddhism, it's considered sacred. There are 108 beads on a mala used for meditation, 108 Upanishads in the sacred texts, 108 names for Buddha. In mathematics, 108 equals 12 times 9, both numbers that appear frequently in sacred geometry and ancient cosmology. The distance between Earth and the Sun is approximately 108 times the Sun's diameter. The distance between Earth and the Moon is approximately 108 times the Moon's diameter. Ancient astronomers noticed these proportions without modern instruments, and some argue they encoded this knowledge in architecture and mythology. Whether these numerical relationships mean anything beyond human pattern recognition is debatable. What's not debatable is that choosing this specific date for a signal, if indeed a signal was sent, would maximize its chance of being noticed by a certain subset of humans, those who track cosmic events, those interested in SETI, those who study the intersection of astronomy and historical anomalies. It's targeting, in other words. If you wanted to communicate with Earth but needed to break through the noise of thousands of asteroids, comets, and space debris that pass through our solar system every year, you might time your message to coincide with a date that already has meaning, that already appears in our databases and cultural memory. You'd create a mirror between past and present, inviting comparison and investigation. This is where we enter territory that makes many scientists deeply uncomfortable. We're linking acclaimed scientific observation to religious history, mixing astronomy with mysticism, allowing narrative and meaning to potentially cloud objective analysis. The criticism is fair and necessary. Confirmation bias is real. Once you decide that a cosmic event is connected to a historical event, you'll start finding connections everywhere, reading significance into details that are actually random. You'll ignore evidence that doesn't fit the pattern and amplify evidence that does. This is how conspiracy theories spread, how pseudoscience masquerades as discovery, how genuine mysteries become buried under layers of wishful thinking. But let's consider the alternative perspective. Throughout human history, major astronomical events have been timed to cultural calendars by observers who wanted to create impact. Ancient priests scheduled ceremonies to coincide with eclipses, demonstrating their power to control the sky. Modern space agencies launch missions on symbolically significant dates. We are, as a species, deeply invested in the relationship between cosmic and cultural time. If an intelligence wanted to send a message that would be recognized, discussed and investigated rather than dismissed as instrumental noise, choosing a date with historical resonance would be strategic, even brilliant. It would create exactly the kind of attention and debate we're engaging in right now. The Fatima event has never been officially explained, but it's also never been confirmed as supernatural by any scientific body. It remains in that liminal space between documented witness testimony and verified phenomenon. Thousands of people saw something, but what they saw doesn't match any standard astronomical or atmospheric process. The October 13th, 2025 event occupies a similar space. Something allegedly happened, the timing is extraordinary, but official verification is absent. We have two mirrors facing each other across a century, each reflecting mysteries the other amplifies, and we have researchers like Sarita connecting them, building a bridge between past and present anomaly. What makes this connection particularly intriguing is that it requires a level of planning that seems almost absurd. If 3i Atlas is a natural object following a gravitational trajectory determined millions of years ago when it was ejected from its parent system, how could its arrival possibly coordinate with human calendar dates and religious anniversaries? The answer is, it couldn't. Not unless someone adjusted that trajectory. Not unless the object isn't following a natural path but a designed one, calculated to arrive at our sun on a specific date with enough precision to create this very conversation. The level of control that would require, the timeline of planning, the understanding of human culture necessary to choose October 13th as a target date, all of this implies an intelligence that's been watching us for a very long time, or it implies that we're so good at finding patterns that we can take a random cosmic event and weave it into a narrative that feels meaningful even when it's not. Both explanations are on the table, both deserve consideration. What we can't do is dismiss the coincidence without examination simply because it makes us uncomfortable, or accept it as proof simply because it feels significant. The mirror exists. 108 years separate two October 13th events. One witnessed by thousands in a Portuguese field, one allegedly detected by instruments monitoring interstellar space. Whether that mirror reflects truth, or reflects our own desire to find meaning in the cosmos is the question that will drive the rest of our investigation. Part 4. The Blackouts and the Missing Eyes. Data is the lifeblood of modern astronomy. We don't discover planets by looking through telescopes anymore. We discover them by analysing gigabytes of light-curve data from orbital observatories. We don't find asteroids by scanning the sky with our eyes. We find them through automated surveys that photograph the entire visible sky every few nights and use algorithms to detect anything that moves between exposures. Every major discovery in the last few decades came from enormous datasets processed by computers, from the detection of gravitational waves to the mapping of the cosmic microwave background. When that data stream gets interrupted, we go blind, and the universe continues to do whatever it does without our witnessing it. Let's build a timeline of the blackouts that cluster around our October 13th, 2025 event. First comes the Psyche mission, a spacecraft launched to study a metal-rich asteroid in the main belt between Mars and Jupiter. From September 1st through September 5th, Psyche experienced a communications blackout. NASA attributed this to a safe mode triggered by onboard systems, a routine protective measure that happens when something goes slightly wrong and the spacecraft needs to stabilize before resuming normal operations. 5 days of darkness during a critical alignment window, when Earth, Mars, and several other solar system objects were positioned in geometries that come around rarely. Next is the HiRISE camera aboard the Mars Reconnaissance Orbiter. HiRISE is one of the most powerful cameras humans have ever sent to another planet, capable of resolving features less than a meter across from orbit. It's given us those stunning high-resolution images of Martian canyons polar ice caps, dust devils, and potential landing sites for future missions. According to David Serida's research, HiRISE went offline on October 1st, 2025. The official explanation involves a failure in the electronics unit for CCD-RED4, one of the camera's imaging sensors, a problem that apparently started degrading back in August of 2023 and finally failed completely by October of 2025. The camera hasn't returned images since. Then comes October 13th. The Solar Dynamics Observatory, NASA's primary real-time solar monitoring satellite, goes offline for what's described as scheduled maintenance. The feed cuts out. For several hours during the exact window when 3i Atlas would have been most active, most visible, potentially emitting those alleged Fibonacci pulses, our best solar observation platform is dark. The timing is precise enough to make you wonder whether the maintenance schedule was quite as routine as presented, or whether something else required the instruments to be taken offline at that specific moment. 3 separate systems, 3 separate missions, all experiencing data gaps during the narrow window when an interstellar object is passing through the inner solar system and potentially doing something extraordinary. Take any one of these events alone and you have a routine technical failure, the kind that happens regularly in the harsh environment of space. Electronics fail, cameras degrade, maintenance gets scheduled. But 3 together, clustered around the same 2-week period, during an event that some researchers claim represents first contact, the statistical odds start to look strange. Not impossible, but strange enough to warrant a closer look at what exactly happened and why. Instrument failures in space are indeed common. The radiation environment beyond Earth's magnetosphere is brutal. Solar particles and cosmic rays constantly bombard spacecraft electronics, gradually degrading components over months and years. Temperature extremes stress materials. In full sunlight, surfaces can reach hundreds of degrees, while in shadow, they plunge to hundreds of degrees below zero. These cycles of expansion and contraction eventually crack solder joints and stress circuit boards. When a spacecraft is designed for a 5-year mission and ends up operating for 15 years, failures become not just likely but inevitable. This is normal. This is expected. Engineers build in redundancy precisely because they know components will die. But there's a difference between random technical failure and coordinated blackout. Random failures should be distributed randomly across time. You'd expect instrument problems to cluster around age, with older systems failing more frequently than newer ones. You'd expect them to correlate with solar activity, with more failures during periods of high radiation. What you wouldn't expect is for multiple unrelated systems to fail within days of each other during the same narrow temporal window, unless something external was affecting all of them simultaneously. And if something external was affecting them, what was it? A solar storm that somehow wasn't recorded? A gravitational wave passing through the inner solar system? Or deliberate action by someone who didn't want certain observations to be made? This is where conspiracy thinking can run away with itself, and we need to be careful. There is no public evidence that NASA or any other space agency deliberately disabled instruments to suppress data about 3i Atlas. The agencies have provided technical explanations for each blackout, explanations that fit within the normal operating parameters of space missions. Accusing them of cover-up without proof isn't just irresponsible, it poisons the conversation and makes it harder to investigate legitimate anomalies. But it's also true that space agencies have histories of classifying data, of delaying releases, of holding back images and observations until they can be properly analysed and vetted. The famous example is the Apollo 11 missing tapes. For decades, the highest quality video of the moon landing was lost, not through conspiracy but through bureaucratic incompetence and poor archival practices. What we can say with confidence is that absence of data creates ambiguity, and ambiguity creates space for speculation. If HiRISE had been operational and photographed 3i Atlas during this window, we'd have high-resolution images that could confirm or deny unusual activity. If the Solar Dynamics Observatory had been recording, we'd have a complete dataset of solar activity during the alleged pulse sequence, allowing independent researchers to look for correlations or anomalies. Without that data, we're left with second-hand claims, individual observations that can't be cross-checked, and a growing sense that something important might have happened just beyond the edge of what we're allowed to see. Amateur astronomers tried to fill the gap, and some claim they observed unusual activity around 3i Atlas. But amateur equipment lacks the resolution and sensitivity of orbital platforms. Ground-based observation has to contend with atmospheric distortion, light pollution, weather, and the fact that small distant objects simply don't show much detail, even through large telescopes. The professionals have the tools we need, and during the critical window, those tools were pointed elsewhere, powered down or returning blank data. Whether by accident or design, we missed the moment when verification was possible. In science, negative results are supposed to be published. If you run an experiment and find nothing, that's valuable information. It tells other researchers they don't need to repeat your work. It helps narrow down where the answer actually is. But in astronomy, absence of data isn't the same as negative results. No data means no results at all. It means the question remains unanswered, hanging in the air, inviting continued speculation and investigation. And when multiple instruments go dark at once, that absence starts to look less like coincidence and more like something systematic, something coordinated. We don't know what, but the pattern demands we ask. Part 5. Enter the hyperdimensional model. This is where our investigation takes a turn into territory that most mainstream scientists would refuse to follow, and I need to be clear about that from the outset. What I'm about to describe is not accepted astrophysics. It's not peer-reviewed. It exists in the speculative fringe where mathematics meets mysticism, where cosmic observation gets interpreted through frameworks that blend science with angelology, where the line between discovery and invention becomes blurry enough that you can't trust your footing. But it's also the framework that David Sarita uses to interpret the 3i Atlas event, and understanding it is essential for understanding his claims about what the Fibonacci sequence means. Sarita proposes what he calls the hyperdimensional solar system model, or HDSSM. In this model, our solar system contains hidden dimensions and orbital positions that correspond not just to physical planets, but to energetic domains and metaphysical orders. He assigns numbers to these positions. 5 represents Earth, our home world, and the anchor point for human observation. 8 corresponds to what he calls Planet 591, identified with the Dominions, one of the 9 orders of angels in medieval Christian cosmology. 13 maps to Virtues, another angelic order, which he associates with the name Methuselah, the biblical figure who supposedly lived 969 years. If your skepticism alarm is ringing loudly right now, that's appropriate. We've left behind observational astronomy and entered a realm of symbolic mapping where numbers have been assigned to metaphysical concepts, and those concepts are then projected back onto physical space to create a model that can't be tested or falsified in any conventional scientific sense. This is the hallmark of pseudoscience, taking real observations, mixing them with untestable claims, and building a structure that feels explanatory but can't actually predict anything or be disproven by evidence. And yet, people who build these kinds of models often start from genuine questions and genuine anomalies. They're trying to make sense of data that doesn't fit mainstream explanations, even if their methods for doing so aren't rigorous. In Sarita's interpretation, when 3i Atlas emitted pulses of 5, 8, 13, it wasn't just demonstrating knowledge of the Fibonacci sequence. It was referencing the HDSSM itself. It was saying, I know about Earth, position 5. I know about the Dominions at position 8. I know about the Virtues at position 13. This would imply that the object, or the intelligence controlling it, has studied not just human mathematics, but human cosmological models, including ones that exist only in esoteric texts and fringe research. It would suggest a level of cultural knowledge that goes far beyond simply recognizing that we're a technological species. It would mean someone has been reading our books, studying our myths, understanding the frameworks through which certain humans interpret reality. This is where the model becomes either incredibly compelling or completely absurd depending on your priors. If you're inclined to believe that angels exist as real entities, occupying specific orbital positions in a higher dimensional structure around our Sun, then the Fibonacci signal takes on profound theological significance. It becomes confirmation that these orders are real, that they can be mapped mathematically, that an interstellar visitor recognized and acknowledged them. If you're a materialist who thinks angels are cultural constructs with no physical reality, then this interpretation is meaningless decoration, applied to an observation that may or may not have even occurred. The model can't be tested. There's no experiment you can run to prove or disprove the existence of Planet 591 or its association with angelic dominions. But let's engage with the idea seriously for a moment, not because we're accepting it as true, but because exploring it reveals something about how humans construct meaning from cosmic events. Mainstream astrophysics recognizes 8 planets in our solar system, plus dwarf planets like Pluto and countless asteroids and comets. We've found no evidence for additional major planets in hidden orbits, though we continue to search for a hypothetical Planet 9 that might explain certain orbital anomalies in the outer solar system. The idea that there are specific positions numerically designated by hidden intelligences, positions that correspond to metaphysical orders rather than gravitational dynamics, isn't science. It's cosmology in the ancient sense, a model of the universe that maps physical space onto spiritual significance. Medieval cosmology did exactly this. Dante's Divine Comedy places Earth at the centre, surrounded by concentric spheres representing the Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn, and finally the fixed stars and the primum mobile, the outermost sphere that imparts motion to everything below it. Beyond that lie the 9, orders of angels and the throne of God. This was a model where physics and theology were inseparable, where orbital motion was explained by angelic intelligence, where mathematics served to reveal divine order. Modern science dismantled that cosmology, replacing it with gravity, inertia, and conservation laws that don't require conscious guidance. But the older model still exists in cultural memory, still shapes how some people interpret what they see in the sky. If 3-Eye Atlas is actually signalling using a framework like Sarita's HDSSM, it suggests an intelligence that understands human culture well enough to reference it, to speak in a language that certain humans will recognize as significant, even if mainstream science dismisses it. That's a sophisticated form of communication, not broadcasting to everyone, but encoding messages that only certain communities will decode. It's targeted signaling, it's choosing your audience. And if that's what's happening, it raises the question of why. Why would an interstellar intelligence care about medieval angelology? Why reference frameworks that most humans have forgotten and that science abandoned centuries ago, unless those frameworks contain something true, something about the structure of reality that we've overlooked in our rush toward materialist reductionism, or unless we're projecting meaning onto random events, seeing in the cosmos what we already believe, constructing elaborate interpretations that say more about our psychology than about any objective signal. Both possibilities remain on the table. The hyperdimensional solar system model is not science, but it is meaning-making, and meaning-making is what humans do when faced with the unknown. We build models, maps, frameworks that let us feel like we understand, even when we don't. Sometimes those models lead to breakthrough discoveries. More often they lead to dead ends. The challenge is telling the difference before you've invested too much in the wrong path. Part 6. Dante's 704-year countdown. In 1321, Dante Alighieri completed his masterwork, the Divine Comedy. The third part, Paradiso, describes his visionary journey through the celestial spheres, guided by Beatrice, ascending through planetary orbits and angelic orders until he reaches the Empyrean and glimpses the divine essence itself. The text is saturated with mathematical and astronomical detail. Dante knew the science of his time. The Ptolemaic model with Earth at the centre, the ratios and harmonies believed to govern planetary motion, the numerology of medieval Christian mysticism. He encoded these patterns into his verse structure, his character choices, his symbolic geography. Scholars have spent 7 centuries decoding layers of meaning they're still finding new patterns in the text. David Sarita argues that Dante didn't just describe the cosmos as he understood it. He encoded a countdown from 1321, when Paradiso was completed, to 2025, when 3-Eye Atlas arrives, is exactly 704 years. That number appears nowhere in the Fibonacci sequence, but Sarita connects it through other mathematical pathways to cycles he believes govern cosmic events. 704 can be factored as 16 times 44. 44 shows up in various sacred geometry systems. 16 is 2 to the 4th power, and if you're willing to follow chains of association far enough, you can link 704 to 432 Hz, a frequency that some alternative researchers claim as a universal resonance, the natural harmonic of the cosmos itself. Now we need to take a step back and recognise what we're doing here. We're taking a number that emerges from simple subtraction, 2025 minus 1321 and reverse engineering significance by factoring it and looking for connections to other systems. This is numerology, not mathematics. Mathematics is about necessary relationships, equations that hold true regardless of how you manipulate them, predictions that can be tested. Numerology is about sufficient relationships, finding any pathway that connects your starting point to your desired endpoint, seeing patterns because you've decided they're there. You can make almost any number seem significant if you're willing to factor it creatively and cherry-pick which associated meanings to emphasize. But let's grant that the 704-year gap might mean something, not because of numerical magic, but because of cultural timing. If an intelligence wanted to reference Western civilization's cosmological thinking, Dante's Paradiso represents a peak moment, a comprehensive synthesis of medieval astronomy, theology, and poetry. It's a text that has survived for 7 centuries, been translated into dozens of languages, studied by millions of students. It's part of the deep cultural memory of European-descended societies and the broader literate world. Choosing a 704-year interval from its completion to send a signal would create a connection that literature scholars and historians might notice, even if astronomers didn't. Dante's cosmology places angels at specific spheres surrounding Earth. The moon's sphere contains angels who failed to maintain their vows. Mercury holds those who did good for glory. Venus contains the lovers. The sun holds the wise. Mars the warriors. Jupiter the just rulers. Saturn the contemplatives. Beyond Saturn, the fixed stars contain the church triumphant, and then come the 3 highest orders of angels: thrones, cherubim, and seraphim. Each sphere has its mathematics, its music, its characteristic light. This is cosmology as geometry, space as nested perfection. It's a model where physical and spiritual occupy the same locations, where you can travel through both simultaneously by ascending in understanding. Medieval minds found this deeply satisfying because it explained everything: why planets moved, what angels did, where souls went, how prayer worked. Modern astronomy dismantled this structure stone by stone. Earth isn't the centre, it orbits the sun. Planets don't need angels to push them. Gravity handles that. The spheres don't exist as physical structures. Space is mostly empty vacuum. The stars aren't fixed to a crystalline shell. They're suns like ours at various distances. We gained accuracy and predictive power but lost the sense of cosmic purpose. The feeling that the universe was built as a home for consciousness, that every layer of reality pointed toward meaning. Some people never quite accepted that trade. They've spent the intervening centuries looking for ways to restore significance to the cosmos, to find the hidden orders that mainstream science says aren't there. If you're one of those people, and an interstellar object arrives exactly 704 years after Dante completed the text that mapped those hidden orders, you're going to pay attention. You're going to look for other connections, other alignments. You're going to ask whether maybe, just maybe, the medieval mystics saw something real that we've trained ourselves not to see. You're going to wonder whether Paradiso was descriptive rather than imaginative, whether Dante actually visited those spheres in some mode of consciousness we no longer access, and whether he encoded the timing of future cosmic events in his verse as a message to whoever would be alive when those events occurred. This is the challenge with investigating claims like Sarita's. They exist at the intersection of historical scholarship, mystical interpretation, and cosmic observation. You can't disprove them because they're not making falsifiable predictions. They're offering narratives that connect disparate data points through frameworks of meaning rather than mechanisms of cause. And narratives are powerful. They're how humans understand reality. We don't think in equations naturally. We think in stories. When someone offers a story that makes the universe feel intentional again, that suggests our species and our cultural history matter to intelligences beyond Earth, that story has emotional appeal independent of whether it's factually true. The 704-year countdown might be real, or it might be a number that emerged from calendar math and then acquired significance through retrospective interpretation. We'd need evidence to distinguish between these possibilities. Other dated predictions from Dante that came true, independent confirmation that something cosmically significant happened in 1321 that set a timer running, some mechanism by which a 14th century poet could know when an interstellar object would arrive. Without that evidence, we're left with a fascinating coincidence that might be the thread connecting a tapestry of meaning, or might be a random data point we've decorated with too much importance. What's undeniable is that Dante wrote about cosmic geometry, that his text has influenced how millions of people think about the structure of reality, and that if you're looking for cultural touchstones that an observing intelligence might use to signal recognition, medieval cosmology is a reasonable candidate. The great cathedrals were built according to sacred proportions. The monasteries preserved astronomical knowledge through the Dark Ages. The scholars of that era were the scientists of their time, trying to understand creation through the tools available to them. If those tools led them to truths we've forgotten, truths that still resonate in the structure of the universe even though we explain them differently now, then revisiting their frameworks might not be nostalgia or pseudoscience. It might be recovering lost knowledge, or it might be confirmation bias dressed in historical costume, finding what we want to find because the alternative, that the cosmos is indifferent and our meanings are self-generated, is too bleak to accept. Both possibilities echo through the 7 centuries separating Dante's pen from the alleged pulses of Three-Eye Atlas, and both will follow us through the rest of this investigation. Part 7. The Sacred Geometry Bridge. Walk into Notre Dame Cathedral in Paris, assuming you could before the fire, and look up at the rose window on the western facade. The stonework divides the circular opening into 12 major segments, each subdivided according to precise ratios. The overall diameter relates to the window's distance from the floor in proportions that approximate the golden ratio. Light floods through coloured glass arranged in patterns that medieval architects believed reflected the order of heaven. This wasn't decoration. It was theology made visible, mathematics given form, an attempt to construct earthly spaces that resonated with cosmic harmony. The builders knew their Euclid, knew their Pythagoras, knew that certain proportions produced visual and auditory harmony, while others produced dissonance. The same proportions show up in Islamic architecture. The Great Mosque of Cordoba, the Alhambra in Granada, the Taj Mahal in India, all employ geometric patterns based on ratios that recur throughout nature. Tile work repeats in fractal-like arrangements. Arches follow curves derived from compass and straight-edge constructions. Dome proportions reflect careful calculation of stress and weight distribution, but also symbolic meanings. The dome represents heaven, the square base represents earth, and the transition between them follows mathematical transformations that medieval engineers understood as sacred. These weren't primitive people guessing. They were sophisticated mathematicians working within cosmological frameworks that unified physics, aesthetics, and spirituality. Mayan glyphs and temple alignments demonstrate similar knowledge. The pyramid at Chichen Itza cast a serpent-shaped shadow at the equinoxes, an effect that requires precise calculation of angles, dates, and solar positions. The Dresden Codex contains Venus tables accurate enough to predict that planets' appearances decades in advance. These were astronomers who tracked cycles, found patterns, and encoded their knowledge in architecture that still stands centuries later. The mathematics they used are the same mathematics we use now, just expressed differently, calculated without computers or telescopes, but with patience and multi-generational observation. What connects all these traditions is the recognition that certain ratios appear everywhere, in music, in growth patterns, in planetary orbits, in the human body. The golden ratio, phi, shows up so consistently that it's tempting to call it a universal constant of form. It's not a physical constant like the speed of light or the gravitational constant, but it's something perhaps more fundamental. The proportion that emerges when systems optimize for efficiency, stability, beauty. Nautilus shells grow in golden spirals because that's the most efficient way to add material while maintaining structural integrity. Galaxy arms spiral according to the same ratio because that's how density waves propagate through rotating systems. The universe, at multiple scales, seems to have discovered the same elegant solution to the problem of growth in constrained space. If an intelligence from another solar system wanted to announce itself, using Fibonacci and the golden ratio would be choosing a language that any technological civilization would recognize, not because these numbers are human inventions, but because they're universal discoveries. Math isn't arbitrary. The theorems of geometry are the same everywhere. An alien species with completely different biology, different chemistry, different evolutionary history would still find that the ratio of consecutive Fibonacci numbers converges on 1.618. They'd still discover that this ratio produces the most efficient spirals. They'd still find it in their own world's biology and planetary dynamics. It's a handshake that works across any divide of time, distance, or form. This is what makes the 3-Eye Atlas claim so compelling to people who accept it. The object allegedly chose to communicate using a pattern that appears in sacred architecture across human cultures, that underlies natural growth from sunflowers to galaxies, that represents one of the few truly universal discoveries mathematics offers. If that choice was deliberate, it demonstrates not just intelligence but sophistication. The understanding that communication requires finding common ground, that you announce yourself by speaking in vocabulary the receiver already knows. 5, 8, 13 aren't random numbers. They're the opening phrase of a language both parties speak fluently, though they learned it from completely different sources, but we need to remain cautious about spiritualizing this too much. The golden ratio appears in nature because of physics and evolution, not because the universe is trying to communicate aesthetic truths. Spirals form when systems rotate and grow simultaneously. Fibonacci sequences emerge from recursive rules. These are consequences of how matter and energy behave, not evidence of conscious design. Finding the same patterns in human architecture means we noticed what was already there and incorporated it into our buildings, because it looked right, because our visual systems evolved to recognize harmony, because structures built to those proportions were more stable and required less material. The sacred geometry is real in the sense that the mathematics is real. Whether it's sacred in any deeper sense remains an open question. If 3-Eye Atlas actually emitted Fibonacci pulses, we're left asking, is it speaking the language of physics or the language of meaning? The two might be identical. Mathematics might be the bridge between consciousness and cosmos, the common ground where minds find each other regardless of substrate or origin. Or we might be projecting human meanings onto natural phenomena that follow mathematical rules for purely mechanical reasons, with no consciousness involved at all. The cathedral builders thought they were revealing divine order. Modern physicists think they're discovering natural law. Maybe both perspectives see part of the truth. Maybe the universe is mathematical in a way that makes consciousness and structure inseparable, that makes pattern and meaning two descriptions of the same underlying reality. Or maybe we're still doing what humans have always done, looking at the stars and seeing ourselves reflected back, hearing in the cosmic silence the echoes of our own questions, finding in the spiral of galaxies confirmation of patterns we already believed were significant. The geometry is real, the spirals exist. Whether they form a bridge between human culture and alien intelligence, or just between human observation and human interpretation, will depend on evidence we don't yet have. But the bridge stands, spanning the gap between our medieval cathedrals and the alleged pulses from an interstellar visitor, connecting geometry across 8 centuries and trillions of miles. Part 8. The physics that shouldn't be. Comets are dirty snowballs, or at least that's the standard model. A nucleus of ice mixed with rock and organic compounds, a few kilometres across, left over from the solar system's formation 4.6 billion years ago. Most comets spend eons in the Oort cloud, a spherical shell of frozen objects surrounding the Sun, at distances measured in thousands of astronomical units. Occasionally, gravitational perturbations from passing stars or giant molecular clouds nudge one of these objects inward. It begins the long fall toward the inner solar system, accelerating as the Sun's gravity pulls it closer. When it crosses inside the orbit of Jupiter, solar heating becomes significant. Ice begins to sublimate. Jets of gas and dust spray outward, always pointing away from the Sun because the solar wind and radiation pressure push them. This creates the characteristic tail, which can stretch millions of miles behind the comet as it rounds the Sun. That's the baseline. That's what we expect from natural objects. 3-Eye Atlas, according to various reports from amateur observers and analysts like David Sarida, doesn't follow this pattern completely. Some observers claim to have detected a sunward jet, material moving toward the Sun rather than away from it. This violates basic physics unless something is actively propelling that material, unless the object has some kind of thrust mechanism pointing in a direction that sublimation doesn't explain. Natural outgassing can produce jets at various angles depending on the comet's rotation and where the ice deposits are located under the surface crust, but you don't get sustained sunward jets because there's no mechanism to maintain them against radiation pressure. Then there's the compositional analysis. Spectroscopy of comets typically shows water ice, carbon dioxide ice, ammonia, methane, and silicate dust. It's the primordial mixture from the solar nebula, flash frozen and preserved for billions of years. Some reports suggest 3I Atlas shows unusual spectral signatures, high nickel content, low iron, ratios that don't match typical cometary composition. Nickel-rich objects are usually associated with metallic asteroids, fragments from the cores of protoplanets that differentiated when they were still molten and then got smashed apart in ancient collisions. Finding high nickel in an interstellar object would be interesting but not impossible. Finding it combined with cometary activity, low iron and possible sunward jets starts to build a picture of something that doesn't fit cleanly into our categories. Let me be very clear about the state of the evidence here. These claims are not confirmed by peer-reviewed analysis. NASA and the International Astronomical Union have not released data supporting unusual composition or anomalous jet directions for 3I Atlas. What we have are reports from individuals, some with credentials and access to amateur telescope networks, some with histories of making extraordinary claims that don't always pan out. Without independent verification from multiple professional observatories using calibrated instruments and standardized analysis techniques, we can't treat these reports as established facts. They're interesting. They fit into the broader narrative of anomaly and mystery, but they're not proof. That said, the possibility that 3I Atlas is physically unusual deserves exploration. If it truly is an interstellar object, it came from another solar system, formed under conditions that might differ significantly from those in our solar nebula. Different stellar metallicities, different protoplanetary disk compositions, different thermal histories, all of these could produce objects with compositions that look strange to us. The fact that it's interstellar already makes it extraordinary. Only 2 previous confirmed interstellar objects have passed through our system, Oumuamua in 2017 and Tui Borisov in 2019. Both showed unusual characteristics. Oumuamua exhibited non-gravitational acceleration that couldn't be fully explained by outgassing. Tui Borisov had an unusually high carbon monoxide ratio. These are objects from alien solar systems. We should expect them to be weird. But there's weird, and then there's engineered. A sunward jet suggests active propulsion, not passive response to solar heating. High nickel with low iron suggests deliberate composition, possibly manufactured materials rather than naturally formed rock. If you're designing a probe to travel between stars, you'd optimize for strength, radiation resistance, and minimal mass. A nickel-based alloy might be a good choice. You'd need propulsion for course corrections, for braking when you arrive at your target system, for maneuvering to specific positions at specific times. Sunward jets would make sense if you're trimming your trajectory, if you're slowing down to match orbital velocities with planets you want to observe. Every anomaly taken individually could have a natural explanation. Taken together, they start to sketch an object that behaves more like a spacecraft than a snowball. This is the probe hypothesis, and it's been around since Oumuamua. Harvard astronomer Avi Loeb suggested that Oumuamua's non-gravitational acceleration could be explained if it were a light sail, a thin, reflective structure pushed by radiation pressure, possibly of artificial origin. The mainstream astronomical community pushed back hard against this idea, arguing that extraordinary claims require extraordinary evidence and that we shouldn't jump to alien artifacts when natural explanations might still be found. Loeb countered that science has a bias against considering artificial explanations, that we're so trained to look for natural causes that we might miss genuine techno-signatures when they appear. The debate continues, unresolved, with both sides accusing the other of bias. If 3I Atlas is a probe, it's more sophisticated than Oumuamua. It's not just passing through on a hyperbolic trajectory. It's potentially signalling, potentially timing its arrival, potentially manoeuvring. That implies active operation, which implies either onboard intelligence or remote control, which implies someone is still out there directing it, watching us, waiting to see whether we notice what they're doing. The level of control that would require is extraordinary. The energy budget for an interstellar journey is immense. Accelerating even a small probe to velocities that would cross light years in reasonable time requires power sources we don't have. Slowing down at the destination requires equal energy. Maintaining operation for what could be thousands or millions of years in transit requires engineering that can survive radiation, impacts, component degradation, without repair. Or maybe it's not a probe. Maybe it's just a strange rock from a strange solar system, and we're pattern-seeking again, seeing design where there's only unusual chemistry and coincidental timing. The universe is vast. It contains trillions of stars, each potentially surrounded by planets and debris. The compositional space of possible objects is huge. We've only studied a tiny sample, objects in our own solar system, plus 2.5 confirmed interstellar visitors. Drawing conclusions about what's normal and what's artificial from such a small dataset is premature. We need more data, more observations, more interstellar objects to establish baselines before we can confidently say something is anomalous. But that brings us back to the blackouts. The instruments that could provide that data were offline. The observations that would let us measure composition precisely, track jet directions accurately, map the object's trajectory in enough detail to detect non-gravitational acceleration, those observations either weren't made or haven't been released. We're left with fragments, amateur reports, claims that can't be verified because the verification systems were dark. Whether the physics of 3i Atlas violates natural explanations remains uncertain. What's certain is that the physics matters enormously, because if this object is engineered, if it's actively controlled, if it's deliberately signalling, then we're not investigating an astronomical curiosity. We're documenting first contact. Part 9. Cosmic Silence or Suppression. In 1969, NASA landed humans on the Moon and broadcast the achievement live to a watching world. The images that went out were converted from the high-quality format recorded at the tracking stations into standard television format for distribution. The original high-resolution tapes were supposed to be archived permanently. Instead, they were labelled incorrectly, stored improperly, and eventually recorded over to save money during a tape shortage in the early 1980s. For decades, the highest quality visual record of humanity's greatest space achievement was lost, not through conspiracy, but through bureaucratic failure, cost-cutting, and poor archival practices. This is how institutions handle priceless data sometimes. They lose it, not maliciously, but through incompetence and resource constraints. Space agencies operate with limited budgets, aging infrastructure, and enormous data volumes. Every satellite produces gigabytes of imagery daily. Every deep space probe sends back measurements that need to be stored, catalogued, processed, analysed. The pipeline from raw instrument data to published scientific results involves dozens of steps. Initial quality checks, removal of instrumental artifacts, calibration against known standards, peer review, embargo periods while researchers write papers. Data can sit in this pipeline for months or years before becoming public. Sometimes it never becomes public because no one with access bothers to write it up, or because it's classified for national security reasons, or because it shows something embarrassing that agencies prefer not to discuss. Let's return to our timeline. Psyche goes dark September 1st through 5th. The official explanation is safe mode triggered by onboard anomaly detection. Safe mode is a real thing, a protective state where spacecraft shut down non-essential systems and wait for ground commands before resuming normal operations. It happens regularly. But the timing, during a window when multiple objects were aligned in interesting geometries, when an interstellar visitor was approaching the inner solar system, adds a layer of coincidence that invites questions. Was the safe mode triggered by something Psyche detected? Was it observing something NASA preferred not to have observed? Or was it genuinely just a technical glitch with timing that only seems significant because we're looking for patterns? HiRISE goes offline, October 1st. The camera has been degrading since 2023, a fact that's documented in mission reports. CCD sensors fail gradually in the space environment. Pixels die, electronics drift. Eventually the accumulated damage makes the instrument unusable. This is normal aging. But October 1st puts the failure exactly 12 days before the Fatima anniversary, exactly 12 days before the alleged Fibonacci pulses. The camera that could have photographed Mars with unprecedented resolution during a window, when 3i Atlas was in that region of the solar system, suddenly stops working. Coincidence or convenient timing? Then, October 13th, the Solar Dynamics Observatory maintenance. Satellites do require maintenance. Software gets updated, instruments get recalibrated, orbits get adjusted. Scheduling this work months in advance is standard procedure. but maintenance that happens to coincide exactly with an event that some researchers claim represents first contact looks suspicious, especially when the agency doesn't release detailed justification for why that particular day was chosen for that particular work. Maybe it was random, maybe it was necessary, or maybe someone looked at what was predicted to happen that day and decided the feed should go dark. If you're trying to suppress information about an anomalous cosmic event, you have several options. You can classify the data immediately, stamping it top secret and routing it through intelligence channels instead of scientific ones. This has happened before with certain spy satellite observations. You can delay release indefinitely, citing ongoing analysis, personnel shortages, budget constraints. Data embargoes can last years in some fields. You can release the data but not the analysis tools needed to interpret it, effectively limiting who can actually work with it. Or you can make sure the instruments aren't looking in the first place, scheduling maintenance or experiencing convenient failures during critical windows. Each approach has been used historically for various reasons. The question is whether any of this was applied to 3i Atlas. There's no public evidence that it was. No whistleblowers have come forward with classified datasets. No leaked documents suggest a coordinated effort to suppress observations. The blackouts have official explanations that fit within normal operations. But absence of evidence isn't evidence of absence, especially when you're investigating possible suppression by organisations with the resources and authority to classify information effectively. If data was captured and classified, we wouldn't necessarily know. The people with access would be bound by security clearances and non-disclosure agreements. The institutional incentive would be to continue presenting normal operations publicly while handling the extraordinary privately. This mirrors patterns in UAP and UFO discourse. For decades, military and intelligence agencies denied having serious programs investigating unidentified aerial phenomena. Then, in 2021, official reports confirmed those programs existed, that trained observers had reported objects performing maneuvers that exceeded known technology, that the government took these reports seriously enough to allocate resources for investigation. The public narrative shifted from "these don't exist," and anyone who reports them is mistaken or lying, to "these exist, we don't know what they are, we're investigating." The shift didn't happen because the phenomena changed. It happened because institutional willingness to acknowledge them changed. Could the same pattern apply to 3i Atlas? An object exhibiting characteristics that suggest artificial origin, arriving on a symbolically significant date, potentially communicating through mathematical signals, would be exactly the kind of thing an agency might choose to handle quietly while continuing to present routine operations publicly. Not necessarily out of malevolence, but out of caution. First contact protocols, if they exist, probably call for verification, analysis, consideration of societal impact, and controlled disclosure rather than immediate public announcement. The few people read into such information would be operating under constraints most of us can't imagine. They might believe silence is responsible even if it's frustrating for those outside the circle. Or there might be nothing to disclose. The blackouts might be genuinely coincidental. The observations that were made might show nothing unusual. So readers' claims might be based on misinterpretation or faulty data. We're investigating absence, shadows, the gaps between what we were told and what might have happened. Absence is hard to prove. You can't definitively demonstrate that something exists when the evidence for it is by definition missing or classified. You can only point to patterns, ask questions, and maintain pressure for transparency from institutions that have reasons to be opaque. What we can say with certainty is that the data pipeline matters. How observations flow from instruments to scientists to the public determines what realities become consensus and what realities remain disputed. When that pipeline has blackouts during critical windows, intentional or not, it creates information asymmetries that undermine trust. Even if nothing extraordinary happened, the perception that something might have happened and was covered up becomes its own kind of reality, shaping how people interpret future events and whether they believe official narratives. The silence around 3i Atlas, whether cosmic or institutional, is now part of the story we're trying to understand. Part 10. The Psychology of Fibonacci Fever. August 15th, 1977, 11:23 p.m. The Big Ear radio telescope at Ohio State University detects a strong narrowband signal lasting 72 seconds, exactly matching the expected signature of an artificial transmission from deep space. The signal is so strong, so clearly different from background noise, that astronomer Jerry Eman circles it on the printout and writes "Wow" in the margin. The name sticks, the wow signal. Searches of the same region of sky in subsequent nights, months, years find nothing. No repeat transmission, no explanation. To this day, it remains one of the most compelling candidate signals in SETI history, and also one of the most frustrating because it never happened again. This is the nature of anomaly detection in astronomy. You see something once, something extraordinary, and then it vanishes. Was it real? Was it an instrumental glitch? Was it interference from a passing satellite or ground-based transmitter? Was it a natural astrophysical burst that mimicked an artificial signal? Without repeatability, without multiple detections from multiple instruments, you can't be sure. Science requires reproducibility. One-off observations, no matter how striking, don't constitute proof. They constitute curiosities, things that deserve investigation, but can't be accepted as established phenomena until confirmed independently. The human brain didn't evolve to deal with this ambiguity. We evolved on ancestral savannas where pattern recognition was survival. The rustle in the grass might be wind, or it might be a predator. The shadow on the path might be a stick, or it might be a snake. Getting it wrong in one direction means you startle unnecessarily and waste energy. Getting it wrong in the other direction means you get eaten. Natural selection strongly favours false positives over false negatives in threat detection. Better to see 10 patterns that aren't there than to miss the one that is. This cognitive bias, this tendency to see patterns even in randomness, has a name: apophenia. We can't turn it off. It's wired into our neural architecture. Fibonacci sequences are particularly susceptible to apophenia because they genuinely appear everywhere in nature. You can find them in flower petals, in tree branching patterns, in the spirals of hurricanes, in the proportions of financial markets. This ubiquity means that if you're looking for Fibonacci, you'll find it, whether or not it actually signifies anything in the particular context you're examining. The sequence is real. The question is whether its appearance in any given situation represents design, natural law, or coincidental matching of patterns that occur frequently. Consider Tabby's star, officially designated KIC 8462852. In 2015, analysis of Kepler Space Telescope data showed this star exhibited bizarre dimming patterns, losing up to 22% of its light in irregular intervals. Normal planetary transits dim a star by 1% or less, and follow predictable schedules. Tabby's star dimming looked like nothing seen before. One hypothesis proposed by astronomer Jason Wright suggested it might be a Dyson sphere or other megastructure built by an advanced civilization to harvest stellar energy. The idea captured public imagination. Articles proclaimed possible alien megastructures. SETI turned radio telescopes toward the star. And then further analysis found a natural explanation. A disk of dust and debris, possibly from a disrupted comet, passing in front of the star at irregular intervals. The megastructure hypothesis died quietly, replaced by mundane astrophysics. This pattern repeats throughout SETI history. Fast radio bursts, when first detected, looked artificial. Precise durations, enormous energies, no obvious natural source. Turns out they're probably magnetar flares, natural but exotic. Pulsars, when first discovered in 1967, were briefly designated LGM1 for little green men, because their regularity seemed too perfect for nature. Turns out they're rotating neutron stars, natural but extraordinary. Oumuamua's acceleration looked anomalous enough to inspire artifact hypotheses. Ongoing analysis suggests cometary outgassing combined with unusual shape can explain most of the observations, though debates continue. Again and again, we see patterns that look designed, that trigger our intelligence detection circuits, and then find natural mechanisms that produce those patterns without requiring consciousness. Does this mean we should dismiss every anomaly as apophenia? Assume that natural explanations will eventually be found for everything unusual? That would be the opposite error. Science advances by taking anomalies seriously, by investigating them thoroughly, by entertaining multiple hypotheses until evidence decisively favours one over the others. Dismissing the Fibonacci pulse claim without investigation, because most SETI candidates turn out to be natural, would be as biased as accepting it immediately because we want first contact to be real. The correct approach is skeptical investigation. Treat the claim as a hypothesis to be tested, rather than a truth to be defended or a delusion to be mocked. So let's test it psychologically. If you're designing a first contact signal, would you use Fibonacci? Yes, for all the reasons we've discussed. It's universal, recognizable, demonstrates mathematical sophistication, appears in both natural and technological contexts. It's the kind of pattern that would light up human pattern recognition systems immediately. An engineer trying to get our attention could hardly choose better. But this is exactly what makes it dangerous from a false positive perspective. Because it works so well as a signal, we're primed to interpret it as one even when it occurs naturally. The very ubiquity that makes Fibonacci a good communication choice makes it a poor discriminator between intentional and accidental patterns. Here's the thought experiment I want you to consider. Imagine you're monitoring space, and you detect 5 pulses from an object, then 8, then 13. Your brain immediately flags this as Fibonacci. You get excited. You start looking for corroborating evidence, for other anomalies that support the interpretation that this is a designed signal. You find compositional oddities, blackout timings, historical anniversary connections. Each additional piece of evidence increases your confidence that you've found something extraordinary. But now ask yourself, if the 5, 8, 13 sequence was purely coincidental, would you still find supporting evidence? Would your pattern-seeking brain still locate compositional oddities, timing coincidences, historical connections? Because that's what human brains do when they're convinced they're onto something? The answer is almost certainly yes. Confirmation bias ensures that once you've adopted a hypothesis, you'll selectively attend to evidence supporting it and minimize evidence contradicting it. This doesn't make you foolish or deluded, it makes you human. Every scientist struggles with this. The solution is systematic methodology, pre-register hypotheses, use blind analysis where possible, require independent replication, submit to peer review by people incentivized to find your mistakes. These safeguards exist precisely because individual human judgment is unreliable when pattern recognition and desire align. We don't have those safeguards for the 3i Atlas case because the primary data is unavailable or unverified. We're working with second-hand reports, gaps in coverage, and a narrative constructed by researchers who are already convinced something extraordinary happened. That doesn't mean they're wrong. It means we're in the early, messy phase of investigation where signal and noise are still tangled, where legitimate discovery and wishful thinking look similar, where the story is compelling enough to continue investigating, but not solid enough to draw conclusions. The psychology of Fibonacci fever, of seeing 5, 8, 13 and immediately thinking message, is both our greatest asset and our greatest liability in searching for cosmic intelligence. It means we'll notice patterns that might actually be signals. It also means we'll chase phantoms, invest resources in false positives, occasionally embarrass ourselves with premature announcements. The key is maintaining the tension, staying open to extraordinary possibilities while demanding extraordinary evidence, recognizing patterns while questioning whether those patterns mean what we think they mean, and always checking whether our desire for contact is shaping what we see in the data more than the data is shaping what we believe. Part 11. The strange quark plasma at CERN. 2,500 feet beneath the border between Switzerland and France, protons race around a 17-mile ring at 99.9999% the speed of light. When these protons collide inside the detectors of the Large Hadron Collider, they release energies that haven't existed naturally in the universe since microseconds after the Big Bang. Matter vaporizes into its constituent quarks and gluons, forming a state called quark-gluon plasma, a primordial soup that filled the entire cosmos before it cooled enough for protons and neutrons to form. CERN physicists study this plasma to understand the fundamental forces that govern matter, to test theories about how the universe evolved from perfect symmetry into the structured complexity we inhabit now. In October 2025, results published from recent collision runs showed something unexpected in the quark-gluon plasma behavior. The plasma was flowing in patterns that didn't match standard hydrodynamic models. Instead of behaving like a simple fluid with uniform properties, it exhibited structure, vortices, flows that suggested additional degrees of freedom, hidden variables influencing how quarks and gluons interact at extreme densities. The physics community is being cautious, running more collisions, checking calibrations, making sure this isn't instrumental artifact. But if the anomaly holds, it suggests that our understanding of matter at the most fundamental level is incomplete, that new physics lurks in the plasma waiting to be decoded. Why does this matter for our investigation of 3I Atlas? Because we might be living through a moment when hidden patterns are revealing themselves across multiple scales simultaneously. At the particle physics scale, the smallest we can probe, quark-gluon plasma shows unexpected structure. At the cosmic scale, the largest we observe, an interstellar object potentially signals using mathematical patterns. Between these extremes lies everything we think we understand about reality: atoms, chemistry, biology, planets, stars, galaxies. If both boundaries are showing anomalies at the same time, it raises the question of whether something fundamental is changing, whether we're entering a period where the universe is speaking more clearly, offering insights we missed before because we weren't looking in the right way or at the right time. This is admittedly speculative. There's no obvious mechanism connecting quark-gluon plasma behavior at CERN with pulse patterns from an interstellar comet. They're different phenomena governed by different physics at different energy scales. But science history shows that breakthroughs often come in clusters. Quantum mechanics, relativity, nuclear physics all emerged within a few decades of each other in the early 20th century, not because the universe changed, but because experimental capabilities and theoretical frameworks reached critical thresholds simultaneously. Instruments got good enough to probe regimes that revealed inadequacies in classical physics. Mathematicians developed tools sophisticated enough to describe what physicists were observing. The breakthroughs fed on each other, creating a cascade of discovery. Could we be in a similar moment now? Instruments have reached extraordinary precision. The James Webb Space Telescope sees the first galaxies. Gravitational wave detectors sense colliding black holes billions of light years away. The Event Horizon Telescope images the event horizon itself. Particle colliders probe energies approaching the Planck scale. AI systems process data volumes that would take human researchers lifetimes to analyse. We have more capability to observe, measure and compute than ever before in human history. If the universe has patterns waiting to be found, we're better equipped to find them now than at any previous point. And if those patterns exist at multiple scales, we'd expect them to emerge across different fields around the same time as various instruments cross critical sensitivity thresholds. The quark-gluon plasma anomaly might connect to cosmic signals through fundamental mathematics. Both involve patterns, structures emerging from what should be simpler systems. Quark plasma should behave like a nearly ideal fluid, its viscosity so low that hydrodynamic equations with standard parameters should predict its flow. Instead, it shows complexity, structure, behavior that hints at deeper rules governing how fundamental particles interact under extreme conditions. Similarly, if 3I Atlas is natural, it should behave like other comets: chaotic outgassing, random jets, composition matching solar system formation conditions. Instead, it allegedly shows structure, patterns, timing that hints at deeper organisation governing its behaviour. In both cases, we're seeing potential evidence that reality is more organised, more structured, more intentional than reductionist physics predicts. Or we're seeing noise that looks like signal because we're desperate for the universe to mean something. The quark-gluon plasma findings are preliminary. They might disappear with better statistics, refined analysis, improved understanding of detector response. Scientific history is littered with anomalies that vanished under scrutiny, measurements that turned out to be systematic errors, patterns that were artifacts of the measurement process rather than features of the phenomenon being measured, cold fusion, faster-than-light neutrinos, the pentaquark that wasn't, all initially looked like revolutionary discoveries before being explained away or retracted. Extraordinary claims in physics face extraordinary scrutiny precisely because getting it wrong is easy, and getting it right is hard. But let's stay with the possibility that both anomalies are real for a moment. What would it mean if quark-gluon plasma exhibits unexpected structure and an interstellar object exhibits mathematical signalling? It would suggest that organisation, pattern, information processing capacity might be more fundamental to physics than we currently believe. Modern physics treats information as a secondary property that emerges from matter and energy following dynamical laws. But some theoretical physicists argue the reverse, that information is primary, that the universe is fundamentally computational, that what we call physical laws are actually algorithms running on a substrate we don't yet understand. In this view, particles aren't little billiard balls following trajectories. They're information states evolving according to rules, and matter is what information looks like when it organizes itself in certain stable patterns. If information is fundamental, then pattern generation and pattern recognition become cosmic principles rather than biological accidents. Fibonacci sequences don't just appear in nature because of mechanical growth rules. They appear because the universe's information processing architecture favors certain recursive structures. Intelligence doesn't emerge accidentally from sufficiently complex neural networks. It emerges inevitably because intelligence is what happens when information systems reach critical complexity thresholds. And communication between intelligences becomes not a rare accident requiring specific technological development, but a natural consequence of information-rich systems interacting across space and time. This is highly speculative theoretical territory, but it's where cutting-edge physics and cosmology are heading. Quantum information theory, holographic principles, computational universe models all suggest that information might be more fundamental than matter. If that's true, then finding mathematical patterns at multiple scales simultaneously wouldn't be coincidence. It would be evidence that we're finally developing the conceptual and technological tools to see what was there all along. The universe as organized information, consciousness as local information processing, communication as information transfer, and signals like the alleged Fibonacci pulses as one information system reaching out to another across the void. The CERN anomaly and the Atlas signal might be connected not mechanically, but conceptually. They're both potentially instances of pattern emerging where we expected simpler behaviour. They're both challenges to reductionist models that assume you can explain complex phenomena by breaking them down into simple components following simple rules. They're both invitations to consider whether organisation and structure might be intrinsic to physical law rather than accidental consequences of initial conditions. And they're both, crucially, occurring at a moment when our civilization has just barely developed the capacity to detect them. A century earlier, we couldn't have built the LHC or tracked interstellar objects with sufficient precision. A century from now, if we survive, we'll look back at this moment and either see it as the beginning of a profound shift in understanding, or as another false dawn in the long history of pattern-seeking primates mistaking noise for signal. The quark-gluon plasma is still being analysed. Papers are being written, peer review is grinding forward, reproducibility is being tested. By the time this investigation concludes, we'll have more data. Either the anomaly will hold and revolutionise our understanding of matter, or it will fade and join the long list of preliminary results that didn't pan out. But right now, in October 2025, it exists in superposition, simultaneously evidence of new physics and possibly instrumental artifact, just like the Fibonacci pulses from 3i Atlas exist in superposition between first contact and wishful interpretation. We live, perpetually, in this moment of uncertainty before resolution. It's uncomfortable, but it's also where discovery happens in the gap between seeing something and knowing what we've seen. Part 12. Solar maximum surprises. The Sun breathes in an 11-year cycle, its magnetic field strengthening and weakening, flipping polarity, driving the appearance and disappearance of sunspots on its surface. Solar minimum is quiet. Few spots, few flares, reduced radiation. Solar maximum is violent. The surface erupts with magnetic activity. Flares release enormous bursts of X-rays and particles. Coronal mass ejections hurl billions of tons of plasma into space at millions of miles per hour. We're currently approaching solar maximum in cycle 25, and it's proving more energetic than predicted. The model suggested a relatively weak maximum, similar to the previous cycle. Instead, we're seeing sunspot numbers and flare frequencies exceeding forecasts, suggesting the Sun has surprises, left that our models haven't captured. Coronal mass ejections, CMEs, are the most dramatic solar events. A massive magnetic structure becomes unstable and erupts, launching a bubble of plasma and magnetic field away from the Sun. If that bubble happens to be aimed at Earth, and if Earth happens to be in its path days later when it arrives, the consequences can be significant. The plasma impacts Earth's magnetosphere, compressing it, inducing currents in the ionosphere, creating beautiful auroras at high latitudes and potentially damaging effects on satellites, power grids, and communication systems. The Carrington event of 1859, the most powerful geomagnetic storm in recorded history, caused telegraph systems worldwide to fail, with some operators receiving shocks and telegraph paper catching fire. A similar event today would be catastrophic for our technology-dependent civilization. October the 2025's heightened solar activity coincides, perhaps meaningfully, perhaps coincidentally, with the 3I Atlas event. The Sun was particularly active around October 13th. Multiple C-class and M-class flares were recorded in the days surrounding that date. The Solar Dynamics Observatory going offline during this period, officially for maintenance, meant we missed high-resolution observations of some of this activity. Could there be a connection between solar dynamics and the alleged interstellar signal? Several possibilities present themselves, ranging from plausible to wildly speculative. First, the electromagnetic environment around Earth and throughout the inner solar system is heavily influenced by solar activity. Radio noise increases during flares, plasma densities fluctuate, magnetic fields distort. If 3I Atlas were attempting to send a signal, these factors could interfere with reception or transmission. The object might have timed its Fibonacci pulses for a moment when solar activity was high, precisely because it wanted to use the sun's energy, possibly amplifying a weak signal by modulating solar emissions in some way. This would be extraordinarily sophisticated, hijacking a star's output to carry your message, using natural energy sources to broadcast more powerfully than your onboard systems could manage alone. Second, if the object is indeed artificially controlled, solar activity might provide cover. A flash from an object near the sun during a period of intense solar flares could be dismissed as natural solar phenomena, allowing the object to signal without drawing immediate attention from automated detection systems designed to identify anomalous emissions. This would be strategic signaling, hiding your message in the noise, visible to anyone looking carefully, but ignorable by automated filters. It's the cosmic equivalent of steganography, embedding signal in carrier waves of natural activity. Third, and most speculatively, the solar maximum itself might be the trigger rather than background. Some researchers in fringe physics communities propose that solar activity influences not just electromagnetic conditions but consciousness, that increased solar flux affects human cognition, creativity, even societal trends. The evidence for this is weak, consisting mostly of correlations that could easily be coincidental, but the hypothesis persists. If solar maxima do affect consciousness, and if an intelligence wanted to communicate during a moment when human minds were maximally receptive, choosing a solar maximum would be strategic timing. We'd be more likely to notice patterns, more likely to make intuitive leaps, more open to extraordinary possibilities during periods of heightened solar activity. The problem with all these scenarios is that they require the signaling intelligence to have detailed knowledge of solar dynamics, Earth's electromagnetic environment, and possibly even human psychology. That level of knowledge doesn't develop from distant observation. It requires proximity, long-term study, possibly even previous visits we don't remember, or that weren't recorded. This pushes us into territory where the hypothesis keeps expanding to accommodate observations, where each new layer of complexity makes the story less falsifiable and therefore less scientific. This is a warning sign. Good theories make precise predictions that can be tested. Theories that keep adding epicycles to match observations eventually collapse under their own complexity. But solar activity is real, measurable, and significant for space weather and technology. The fact that we're in a stronger than predicted maximum is established. The fact that multiple instrument blackouts occurred during this period is documented. Whether those facts connect to an interstellar object signalling mathematically is the question. The sun might be incidental background, or it might be central to the mechanism of communication, or it might be the reason we're misinterpreting natural phenomena as artificial. Solar events produce all sorts of optical effects, radio bursts, magnetic disturbances. Separating signal from solar noise requires careful analysis of exactly the kind of data that wasn't recorded, because instruments were offline. This is the recurring frustration at the centre of this investigation. Every interesting question leads to missing data. Every potential explanation requires observations we don't have. The sun was active. The object was present. The instruments were dark. Did something extraordinary happen in that moment of darkness? Or was the darkness itself the most significant event, preventing us from seeing that nothing extraordinary happened at all? Both possibilities remain open because the evidence needed to close them is absent. What we can say is that the solar maximum adds another layer of complexity to an already complex situation. If you're trying to evaluate whether an interstellar object emitted mathematical pulses, you need to account for what the Sun was doing at that moment, how its activity might have interfered with or enhanced potential signals, whether solar flares could be misinterpreted as object emissions. These are technical questions requiring technical analysis of complete datasets. Until that analysis happens, until the data becomes available, we're speculating about possibilities rather than investigating confirmed phenomena. The Sun blazes, the comet passes, the instruments go dark, and we're left trying to reconstruct what happened from shadows and gaps in second-hand reports. Part 13, AI finds patterns humans can't. In October 2025, Google DeepMind and OpenAI jointly announced new collaborations with cosmology research groups, applying advanced machine learning models to cosmic microwave background data, large-scale structure surveys, and gravitational lensing catalogues. These AI systems are designed to find patterns in data too complex and high-dimensional for human analysis. They've already discovered unexpected structures in the cosmic microwave background, subtle anisotropies that don't match standard inflationary models. They've identified gravitational lensing signatures suggesting dark matter distribution is more clumped than simulations predicted. They're finding patterns, in other words, that we didn't know to look for because we didn't expect them to be there. This represents a fundamental shift in how science operates. For centuries, human scientists formed hypotheses based on theory, designed experiments to test those hypotheses, analysed results, and refined their understanding. The bottleneck was human creativity and attention. We could only look for things we'd imagined might exist. AI removes this constraint. Machine learning systems can scan datasets for any pattern that deviates from randomness, flagging anomalies without preconceptions about what constitutes an anomaly. They might find structures we'd never hypothesize because those structures don't fit into our existing theoretical frameworks. This is powerful, but it's also dangerous. Not every pattern is meaningful. Data contains noise, instrumental artifacts, statistical flukes that look significant but aren't. AI systems are incredibly good at finding patterns, but they're not inherently good at distinguishing meaningful patterns from meaningless ones. This connects directly to our investigation of 3i Atlas, because the alleged Fibonacci pulse sequence is exactly the kind of pattern an AI might flag as anomalous. 5 pulses, then 8, then 13, in a comet's light curve. That's a deviation from expected randomness significant enough to trigger automated alerts. But human judgment is required to evaluate whether that pattern represents signal or noise. Did the comet actually pulse in Fibonacci? Or did the AI find a sequence in noisy data that happens to match Fibonacci, because Fibonacci numbers are common enough that you'll find them, by chance, if you look at enough data? This is the challenge of using AI for anomaly detection. It finds everything, and sorting the wheat from the chaff requires exactly the kind of careful human analysis that's difficult when the underlying data is unavailable or unverified. There's another dimension to consider. If agencies like NASA are using AI to pre-screen data before human analysts see it, the AI might be filtering out anomalies as noise before humans ever become aware of them. Imagine an automated system that scans terabytes of satellite imagery, light curves, spectroscopic data, looking for anything unusual. It's trained on millions of examples of normal comets, normal asteroids, normal stellar behaviour. When something genuinely novel appears, something that doesn't match the training set, the AI has to make a decision, flag it for human review, or classify it as probably instrumental noise and discard it. If the system is tuned to minimize false positives, to avoid overwhelming human analysts with junk detections, it might be too conservative. It might filter out the genuine anomaly along with the noise. This is called the alignment problem in AI research. You design a system to achieve some objective, but the objective you specify isn't quite the same as the objective you actually want, and the system exploits that gap in ways you didn't anticipate. An AI trained to minimize false positive anomaly detections might achieve that goal by never flagging anything as anomalous, even when something genuinely is. You'd have perfect precision but zero recall. The 3i Atlas Fibonacci pulses, if they happened, might have been detected by instruments, processed by AI systems, classified as noise, and discarded. all without any human ever seeing them. We'd never know we missed first contact because the machines we trusted to watch for it decided it didn't fit their models of reality. On the flip side, AI might be creating patterns where none exist. Machine learning systems are notorious for finding spurious correlations, for hallucinating structure in random data, especially when dealing with limited datasets or noisy observations. If an AI trained on cosmic survey data encounters an interstellar object, a type of object it's seen maybe twice before, it has almost nothing to generalize from. It might latch onto random fluctuations in the light curve and interpret them as significant, because it's desperate to fit the data into some category it understands. The Fibonacci sequence could be AI pareidolia, the machine equivalent of seeing faces in clouds, finding 5813 in noise because those numbers have significance in its training data. This is the paradox of AI in astronomy. We need it because human attention doesn't scale to modern data volumes. Surveys like the Legacy Survey of Space and Time will generate tens of terabytes per night once operational. No human team can examine that much data manually, but the AI systems we deploy are black boxes with failure modes we don't fully understand. They make decisions, classifications, judgments that affect what observations reach human awareness. If they're wrong, if they're missing genuine signals or hallucinating false ones, we might not discover the error for years or decades, until someone goes back and reanalyzes archival data with different algorithms and finds what was missed. The question of whether 3i Atlas emitted Fibonacci pulses might ultimately be answered not by better telescopes but by better AI, or by humans finally getting access to the raw data and analysing it independently of whatever automated systems processed it initially. If the data exists and is eventually released, multiple research groups with different analysis pipelines will examine it. Consensus will emerge if the pattern is real and robust. But if the data was discarded by automated systems, or if it's classified and never released, we'll never have that opportunity. We'll be left with researcher claims, debates about methods and interpretations, and the nagging possibility that something important happened just beyond our ability to verify it. The machines watch the sky now, more tirelessly and comprehensively than human eyes ever could. But machines are not neutral observers. They embody the assumptions, priorities, and biases of the humans who programmed them. If those humans didn't imagine that interstellar objects might signal using mathematical patterns, the machines won't be optimized to detect those signals. The universe might be shouting at us in Fibonacci, and our AI gatekeepers might be classifying it as noise because nobody taught them that numbers can be messages, that pattern can be language, that mathematics might be the bridge between our intelligence and others waiting among the stars for us to finally learn the grammar of the cosmos. Part 14, the Mars Mystery Layer. Mars hangs in our sky as both inspiration and warning. A world that once had liquid water, possibly life, now cold and dry with an atmosphere too thin to breathe. We've sent more missions to Mars than to any other planet, orbiting it with reconnaissance satellites, landing rovers on its surface, drilling into rocks, analysing soil chemistry, searching for signs that life ever arose there and whether it might persist in some underground refuge. The Mars Reconnaissance Orbiter, launched in 2006, carries the HiRISE camera, the most powerful imaging system ever sent to another planet. HiRISE can resolve features smaller than a metre across from orbital altitude, producing images so detailed you can see individual boulders, track dust devil trails, map layered geology with extraordinary precision. According to David Sarida's research, HiRISE went offline on October 1st, 2025, due to failure in the CCD Red 4 imaging unit, a component that had been degrading since August 2023. The camera hasn't returned images since. This is independently verifiable to some extent. If you check the HiRISE public archive, image releases do taper off in late 2024 and early 2025, consistent with a failing instrument gradually losing capability before complete failure. The official explanation involves radiation damage accumulating over nearly 2 decades of operation in the harsh Martian orbital environment. Electronics fail. This is expected. The HiRISE mission has already far exceeded its designed lifetime. The camera dying is sad for science, but not suspicious in itself. Except for the timing, October 1st puts the failure exactly 12 days before October 13th, exactly 12 days before the alleged 3i Atlas Fibonacci event. And if 3i Atlas's trajectory brought it near Mars orbit or behind Mars from Earth's perspective, HiRISE would have been one of the few instruments capable of photographing it with sufficient resolution to detect structural details, surface features, anything that might distinguish artificial from natural. With HiRISE offline, we lost that capability at precisely the moment it might have been most valuable. Coincidence? Probably. But coincidences are starting to stack up like cordwood, and at some point you have to ask whether the pile is growing too tall to be accidental. Mars itself occupies an interesting position in the modern mythology of hidden signals and suppressed discoveries. The UAP and UFO communities have long focused on Mars as a potential location for structures or artifacts that might indicate past or present intelligent activity. Photographs from various Mars missions occasionally show rocks or formations that, with sufficient imagination and low-resolution imagery, can be interpreted as artificial. The famous Face on Mars in the Cydonia region, photographed by Viking 1 in 1976, sparked decades of speculation before higher-resolution images from Mars Global Surveyor revealed it as a mesa shaped by wind erosion and lighting angle. Pattern recognition again. We see faces because we're wired to see faces, and Mars has millions of rocks that vaguely resemble something if you squint and want them to. But some researchers maintain that Mars once hosted technological civilization, that structures exist there now, either abandoned or still operational, and that space agencies know this and hide the evidence. This claim is unfalsifiable because any absence of evidence is interpreted as successful suppression. No structures visible in images? That's because the revealing images are classified. Geologists explain formations as natural? That's because geologists are part of the cover-up. It's conspiracy thinking that immunizes itself against disproof. But it persists because Mars is genuinely mysterious, genuinely tantalizing as a target for investigation, and because the agencies involved do classify some data for various legitimate and illegitimate reasons, creating an information environment where paranoia can thrive. If 3i Atlas passed near Mars or occulted behind it from Earth's perspective, and if HiRISE had been operational, what might it have photographed? The object itself, potentially, though whether a comet several kilometres across would show interpretable detail at Mars' orbital altitudes depends on geometry and distance. More importantly, if the object were interacting with Mars in any way, leaving traces, communicating with something on the surface, reflecting signals, that interaction might have been visible. HiRISE images the Martian surface, not deep space, but its pointing system can be commanded to track moving objects if mission controllers prioritize that. With the camera offline, that option didn't exist. The Mars Reconnaissance Orbiter mission continues with other instruments operational. Context. Camera CTX still functions, providing lower resolution but wider field imagery. The Compact Reconnaissance Imaging Spectrometer for Mars CRISM still returns spectroscopic data. The spacecraft's radar sounder continues probing subsurface ice. Only HiRISE is silent. This partial failure is actually more suspicious than complete mission loss would be, because it suggests selective damage or selective shutdown. If something hit the spacecraft with radiation or debris, you'd expect multiple systems to fail. If someone wanted to disable imaging capability while maintaining other functions to avoid raising alarms about total mission loss, you'd shut down the camera specifically. I want to be very careful here. There is zero public evidence that HiRISE was deliberately disabled. The technical explanation involving CCD degradation is consistent with normal aging in the space radiation environment. Reaching for sabotage or suppression without evidence is exactly the kind of reasoning that discredits legitimate investigation. But it's also true that selective failures during critical windows deserve scrutiny, deserve questions about whether official explanations are complete, deserve independent technical assessment by experts who aren't institutionally committed to maintaining the narrative that everything happened according to routine operations. Mars sits between Earth and the outer solar system, a natural waypoint for anything passing through. If an intelligence were approaching our Sun from interstellar space, Mars would be one of the first targets for close study. A planet with atmosphere, with geology indicating liquid water in its past, with polar ice caps and seasonal changes, showing evidence that habitability existed there once, and might exist there again with sufficient terraforming effort. An interstellar probe might reasonably make a Mars flyby for reconnaissance before continuing sunward to Earth, and if that probe's activity during Mars approach was something agencies preferred not to have documented in high resolution, disabling the most capable camera while maintaining other instruments would be one way to manage that. Or high-rise just died of old age at a coincidentally interesting moment, and we're constructing elaborate scenarios because humans are storytelling creatures who can't tolerate ambiguity. The Mars mystery layer adds depth to our investigation, but it also adds complexity that might be illusory. We're layering hypothesis on hypothesis, connection on connection, building a structure that feels meaningful but might be entirely scaffolding with no actual building inside. The challenge is maintaining skepticism while staying open, rejecting paranoia, while acknowledging that institutions do sometimes suppress information, keeping the investigation going without losing ourselves in infinite regress of suppression theories that explain everything and therefore explain nothing. Mars waits, red and cold, its cameras partially blind, its data streams flowing but incomplete. Whatever happened or didn't happen near its orbit in early October 2025 remains unconfirmed, unanalyzed, filed away in whatever databases NASA maintains for eventual analysis that may or may not ever be published. And we wait too, Earthbound, asking questions, building narratives, trying to reconstruct events from the pieces we're allowed to see. Part 15. The Coming Windows. October 19th through 30th, 2025 marks 3I Atlas's closest approach to the Sun, its perihelion, the moment of maximum solar heating, and presumably maximum outgassing activity, if it's truly a comet. But there's a problem for Earth-based observers. The object is behind the Sun from our perspective during this window. We can't see it. Our telescopes can't point through the Sun. The only observers who could track it during this critical period are spacecraft positioned elsewhere in the solar system. Instruments on the far side of the Sun, orbiters at angles that keep the object visible. Most of those instruments are the ones that experience blackouts or failures. The timing is exquisite if you're trying to hide activity, infuriating if you're trying to observe it. By mid-November 2025, 3I Atlas should emerge from behind the Sun as seen from Earth, moving outward on its departure trajectory. This is the next window for observation. If the object is going to do anything else unusual, emit additional signals, demonstrate non-gravitational acceleration, reveal structural details that confirm artificial origin, this is when we might detect it. Amateur astronomers worldwide are presumably targeting it. Professional observatories, if they're interested, have scheduled follow-up observations. The question is whether those observations will be made public promptly, or whether data will be delayed, embargoed, classified, or simply not released because nothing interesting was found. April 3rd, 2026 represents another significant date, the scheduled release of ExoMars data that's currently under embargo. The European Space Agency's ExoMars Trace Gas Orbiter has been monitoring Martian atmosphere since 2016, but some datasets, particularly those from sensitive instruments or involving potential biosignature detections, are embargoed for months or years while researchers analyse them and prepare publications. If any ExoMars instruments observed anything relevant to 3I Atlas during its pass through inner solar system, that data might be in these embargoed archives. When they're released, independent researchers can examine them for anomalies, correlations, anything that mission scientists might have overlooked or chosen not to emphasize. This is how science often works. Initial observations are made, official results are published emphasizing certain findings, and then years later someone reanalyzes the archival data from a different angle and discovers what was missed the first time around. Pulsars, gamma-ray bursts, exoplanets, all were hiding in older datasets before people knew to look for them. If 3I Atlas truly represents something extraordinary, evidence might be scattered across multiple mission archives, unrecognized because no one was connecting the dots. No one realized that the October 13th event required looking at September and November data from Mars orbiters, solar monitoring satellites, Deep Space Network tracking logs, amateur observer reports. The pattern only emerges when you step back and look at everything together. What should you be watching for? First, any repeat of the Fibonacci sequence. If 3I Atlas emits 5813 again during its outbound trajectory, that would be strong evidence the first detection wasn't instrumental noise or misinterpretation. Second, any extension of the sequence, 2134-55 pulses, would indicate intentional continuation of the pattern, a message being elaborated rather than just an opening greeting. Third, any response from Earth-based transmitters. Some researchers might attempt to signal back, transmitting mathematical patterns toward the object to see if it acknowledges reception. This gets into controversial meaty territory, messaging to extraterrestrial intelligence, which some scientists oppose because it announces our presence to potentially dangerous unknowns. But it's likely someone will try it anyway. Fourth, watch for official statements from space agencies. If NASA, ESA or other organisations acknowledge the Fibonacci pulses, confirm the observations, or provide alternative explanations, that represents a significant shift from current silence. If they continue to say nothing, that silence itself is data, suggesting either nothing unusual happened, or something did happen that they prefer not to discuss publicly. Fifth, watch for amateur observer networks and citizen science projects. These distributed observation campaigns can sometimes catch what official instruments miss or choose not to emphasise. Crowdsourced data analysis has found exoplanets, mapped asteroids, identified gamma-ray burst host galaxies. It could find evidence of deliberate signalling from 3i Atlas if that evidence exists and isn't being suppressed at institutional levels. The coming windows are opportunities, moments when the object becomes observable again, when new data might confirm or refute the October claims, when the investigation can move from speculation to verification or falsification. There are also test cases for transparency and scientific openness. Will agencies release data promptly? Will independent researchers be given access to raw observations? Will claims be evaluated on evidence or dismissed because they seem too extraordinary to take seriously? How these questions are answered will tell us as much about human institutions as about cosmic visitors. There's a thought experiment I want to leave you with. If 5813 was the opening statement, what comes next? If this is contact, it's not a one-time event. It's the beginning of communication, a conversation that will unfold over months or years as the object moves through our system, potentially returning later, potentially leaving artifacts or continued monitoring. The Fibonacci sequence is an invitation to pay attention, to watch closely, to recognise pattern as language. The next numbers in the sequence are 21, 34, 55, 89, 144. If you see those numbers in pulses, in object trajectories, in timing of events, that's confirmation. That's the universe or something in it speaking mathematics, proving that the initial contact wasn't accident or interpretation but genuine signal. Or it's our pattern-seeking minds constructing elaborate narratives from chaos, seeing in the cosmos what we desperately want to see. Meaning, intelligence, acknowledgement that we're not alone. Both possibilities remain open because the evidence needed to close them won't arrive until the next observation window, and maybe not even then. Maybe we'll spend years debating October 13th, 2025, arguing about whether humanity received its first confirmed message from beyond our solar system, or whether a community of researchers got excited about instrumental noise during a convenient blackout. Maybe we'll never know for certain, because certainty requires data, and data requires instruments that point the right direction at the right time and share what they see. What's undeniable is that the question has been asked. 5, 8, 13 hangs in our awareness now, a sequence of numbers carrying the possibility of everything or nothing. The coming windows will add more data, more observations, more opportunities for pattern to reveal itself as signal or dissolve into noise. Either way, we're watching now, finally, paying attention to the spaces between planets and the mathematical languages that might bridge species separated by light years and evolutionary gulfs, but connected by the universal grammar of number. If something is out there trying to speak, we're listening. And if we're alone, if the only voice in the cosmos is our own echo returning from empty space, we're learning that too, slowly, through the patient accumulation of silence and absence where we hope to find symphony and presence. The sky continues its ancient rotation. Objects move through orbits determined millions of years ago, or calculated yesterday depending on whether they're natural or guided. Instruments watch, when they're operational, when they're pointed correctly, when someone remembers to check the data. And we wait, suspended between discovery and delusion, watching the calendar for dates that might mean everything, watching the instruments for signals that might never come, watching ourselves for signs that we're learning wisdom, or just accumulating more sophisticated forms of self-deception. The coming windows approach. We'll see what they reveal.